Dear girls, in the online class, in the last session, we have learnt about the quadratic form and how to convert the matrix and how to convert the quadratic form to matrix and matrix to quadratic form. And here we are learning about how to reduce the quadratic form to canonical form or normal form through linear transformation. So for this conversion or for reducing, we need two methods. That is, one is a linear method and another one is a orthogonal transformation. First we will learn about a linear transformation. Here, see the problem, reduce the quadratic form. Okay, 10x square plus 2y square plus 5z square minus 4xy minus 10xz plus 6yz to canonical form, and find its rank, index, signature and nature. Also find the linear transformation. Okay, already I explained you what is a linear transformation. Okay, and linear transformation means we have to write the matrix A is equal to I into A into I, and we have to apply the row and column operations, and we have to reduce to the diagonal matrix. So this is the procedure. So for the easiest, I'm making this video for you. So please be conscious about the problem and please learn. Okay. Now see, the quadratic form is here, and so I'm writing here what is the given quadratic form. Given quadratic form is, okay, so given quadratic form is what we have given: 10x square plus 2y square plus 5z square minus 4xy minus 10xz plus 6yz. Now what is the matrix? When we are reducing to matrix, what is the matrix? So directly we can write as 10, 2, 5. Because we are having three variables x, y and z. So we are having the symmetric matrix of order 3 by 3. Hope you understood. Minus 4xy. We have to share this minus 4xy to both xy and yx. So minus 2, minus 2. And minus 10xz. So we have to share for both xz and zx. So minus 5, minus 5. Plus 6yz. This is shared for both yz and zx. So 3 and 3. Okay. So this is the resultant matrix. Now, what is a linear transformation and what is the canonical form? And we have given the quadratic form Q is equal to x transpose into A into x. I hope you understood now. Q is equal to x transpose into A into x. Now we are transforming to canonical form. What is the canonical form? Okay, first we will write the canonical form is equal to y transpose into D into y. This is the canonical form, right? Now, what is D? D is the diagonal matrix which is reduced from A. Okay, and what is the linear transformation? Okay, so the linear transformation is x is equal to P into y. Okay, then what is P? P is the identity matrix which is reduced. Okay, that is known as P. I will explain you everything. Okay, and now, so Q is equal to the given quadratic form, and this is converted to canonical form which is in terms of y transpose into D into y by using the diagonal matrix. Right, now we will assume as, let A is equal to I into A into I. Now what is A here? 10 minus 2 minus 5 minus 2, 2 and 3 minus 5, 3 and 5. This is the matrix. Okay, this is the A matrix, and this is equal to I into A into I. What is I here? 1 0 0 0 1 0 0 0 and 1. This is I. A into again 1 0 0 0 1 0 0 0 1. Okay, and now what we have to make as this A matrix is reduced to the diagonal matrix D. But the condition is, we can apply both row and column operations, but the condition is, what are the row operations we are applying here? We have to apply the same operations on the first I. What are the column operations we are applying here? We have to apply the same operations on the second I, pre-I and post-I. I hope you understood now the same operations. And one thing we should be very careful, that at last both these identity matrix should be transposed to each other. Okay, so we should be very careful. At last these both should be transposed to each other. For this purpose, what we will do is, what are the row operations we are applying? We apply the same column operations also. Okay, now we have to make these two elements as zeros. So what are the row operations we use here? R2 implies 5R2 plus R1, and R3 implies 2R3 plus R1. So that these two elements will be make it as a 0. Now look at here. This is 10 minus 2 minus 5, and 10 minus 10 plus 10, this is 0, and 10 minus 2, this is 8, and 15 minus 5, this is 10, and the last one 10 minus 10 plus 10, this is 0, 6 minus 2, this is 4, and this is 10 minus 5, this is 5. Okay, and we have applied the row operations. So the same row operations are applied on the first I, that is pre-I, that is 1 0 0, 5 into 0, 0 plus 1, this is 1. Okay, next 5 plus 0, 5, and next one is 0. And the next operation is R3 plus 2R3 plus R1. So 0 plus 1, 1, 0, 2. Okay, and the next I is remaining same because we have used only the row operations. Okay, and the same row operations will be applied to column operations also. So this becomes as C2 implies 5 into C2 plus C1. C3 implies 2 into C3 plus C1. Now what does it happen now? This is 10, 0, 0, and this is minus 10 plus 10, 0, 40 plus 0, 40, 20 plus 0, 20. Now the third column, minus 10 plus 10, 0. Next 20 plus 0, 20. Next 10 plus 0, this is 10. Okay, and here we have applied for the column operation. So the first I will be same. We should not change. And we have to change in the second I, 1 0 0. And 5 C2 plus C1, this is 1. And 5 plus 0, 5. Next 0. Next 2 C3 plus C1, 1, 0, 2. Okay. And now, and what is the element we have to make it as 0 here? This is 20. So for this 20, what we have to do? What is the row operations we have to use here? R3. R3 implies, okay, 2R3 minus R2. Okay, so what does it happen now? This is 10, 0, 0, 0, 40, 20, and here 0. Next 40 minus 40, this is 0. Okay, and next 20 minus 20, this is 0. Okay, and so this is equal to, and here we have applied in the row operations. So the same operations are applied in the first I. So 1 0 0, 1 5 0. Next 2 minus 1, this is 1. And next 0 minus 5, minus 5. Next 4 minus 0, this is 4. Okay, so A, and next one, this is same because we applied for the column operation. So 1 1 1, 0 5 0, 0 0 2. Okay. So this is a, and again, since we have applied the row operations, the same we have to apply for the column operations also. So R3. So this is now coming to the column operations. So now this becomes as C3 implies, okay, 2 into C3 minus C2. The same operation, 2 into C3 minus C2. Okay, now this is 10, 0, 0, 10, 0, 0. The next one is 0, 40, 0, 0, 40, 0. Okay. The next one is, see here, 0, 20, 0. What we have used? C3 implies 2C3 minus C2. So 0 minus 0, 0. 40 minus 40, 0, 0. So the entire column is 0. Now this is 0, 0, 0. Okay. And we have applied for column operation. So the first I will be the same. What is the first I? 1, 0, 0, 1, 5, 0, 1 minus 5, 4. Okay. 1, 0, 0, 1, 5, 0, 1, 5, 0, 1 minus 5, 4. Yes. 1 minus 5 and 4. Okay. This is the first I. What is the second I? Now we have to change 1, 0, 0, 1, 5, 0. 1, 0, 0, 1, 5, 0. The third column we have to convert this. Okay. This is 1, 0, 2. Now what we have to do? 2 minus 1. 1. 0 minus 5. Minus 5. So 1 minus 5 and 4. Right? 1 minus 5 and 4. Okay. I think you understood now. Since we have used the column operations, we have applied for the second matrix. And now what we observed, this is the diagonal matrix, right? This is the diagonal matrix and all the other elements are zeros. So this is one matrix and this is the other matrix. Now what we got? D is equal to P transpose into A into P. Okay. I think you understood now. This is equal, D is equal to P transpose into A into P. Why are we denoting with P? This is not a model matrix. Okay, just for only for denoting, I denoted with this. Because at last we are using X is equal to P into Y. So I used this. Okay, now this is over. And now coming to this. So we have transformed the quadratic form to Y transpose into D into Y. Now what is the canonical form? Now the canonical form is Y transpose into D into Y. Okay. So what is Y and what is X? Here X is equal to, we have having 3 variables. So X1, X2, X3. We denote with this. And what is Y? Okay, same Y is also Y1, Y2, Y3. Okay, this is also the same. Okay, now what is the canonical form? Canonical form is equal to Y transpose into D into Y. This is Y1, Y2, Y3. What is D here? D is equal to 10, 0, 0, 0, 40, 0, 0, 0, 0 and Y is Y1, Y2 and Y3. Okay. Now what is the reduced canonical form? Therefore, the reduced canonical form is Y1 into 10 into Y1. That is 10 into Y1 square plus the same 40 into y2 square plus 0 into y3 square. Therefore, this is the reduced canonical form 10y1 square plus 40y2 square plus 0 y3 square. I hope you understood now. This is the reduced canonical form. Now, what is the linear transformation? So, what is the linear transformation? Linear transformation is x is equal to p into y. What is x here? This is x1, x2, x3. This is equal to what is p? P is equal to what we got here. Because these two are transposed to each other and we are denoting as p transpose into a into p. Now what is p? 1, 1, 1, 0, 5, minus 5, 0, 0, 4. And this is y is equal to y1, y2 and y3. Now what is x1? x1 is equal to y1 plus y2 plus y3. In the same manner, x2 is equal to 0 into y1 plus 5 into y2 minus 5 into y3. In the same manner, what is x3? 0 into y1 plus 0 into y2 plus 4 into y3. So, this is the linear transformation. Okay, so this is the reduced canonical form and this. Now from this, what is the rank? Rank is equal to, we are having two non-zero rows. So rank is equal to, R is equal to 2. Okay, now what is index? Index is equal to, we are denoting with S. S means the number of positive terms. So reduced canonical form, we are having two are positive. We are having three terms, but we have only two values and both the values are positive. So, what are the positive terms? Index S is equal to, S is equal to 2. Now, what is the signature? Already we know the formula. Okay, signature is equal to 2S minus R. That is 2 into 2 minus 2. This is 2. Therefore, rank is 2, index is 2 and signature is 2. Now, what is the nature? Okay, nature is equal to, what are the terms we are having? 10, 40 and 0. These two are positive and one is 0. So, what is the nature? Positive, semi-definite. Okay. So, this is a problem. Girls, so I hope you understood this video. So, if you have any doubts in this video, you please ask me in the class. Okay, I will explain you in the class. Okay, because it is time is wasting with my tablet. I think some problem is there, but I want to make you learn the concept also. Okay, so girls, please be ready. Bye.